Hi everyone. In today's class, we are going to discuss how to measure the power in a three-phase balanced and unbalanced circuit. Objective: at the end of this video, you will be able to measure the three-phase power in an unbalanced load. First, let us have a brief discussion on balanced and unbalanced conditions. Balanced load or system. A balanced load is one in which the load is equally distributed in all three phases of the system. In a balanced system, the current values phase in all the three phases are same. The voltage values phase in all the three phases are same. The phase difference between each phase is 120 degrees. No neutral current. The impedances phases in all the three phases are same. If the load is star connected with neutral as the return path, this neutral will carry no current. This is so since the vector sum of all three phase currents meeting at the common neutral point is 0. Unbalanced load or system. An unbalanced load is one in which the load is unequally distributed in all three phases of the system. In an unbalanced system, voltage and current values in all three phases will not be same with each other, have differences in phase angle from each other phase. A neutral current will occur. The impedances phases in all three phases are not same. Let us discuss this in practical terms. Let's collect the instruments and materials required. 3-phase squirrel cage induction motor, 3 HP, 415 volts with load arrangement 1 number. Capacitor bank, 3-phase, 415 volts, 1.5 kVAR, 1 number. 3-phase power factor meter, 415 volts, 20 amps, 1 number. Wattmeter, 500 volts, 10 amps, 2 numbers. Moving iron ammeter, 10 amps, 1 number. Moving iron voltmeter, 300 volt by 600 volt, 1 number. 4-pole MCB, 16 amps, 1 number. Insulated copper wire, 2.5 square millimeter, 20 meters. Measurement of power in a three-phase star-connected balanced circuit. Let's collect the instruments and materials required for this practical. Single-phase wattmeter, 250 volts, 5 amps, 2 numbers. Moving iron voltmeter, 0 to 500 volts, 1 number. Moving iron ammeter, 5 amps, 1 number. 4-pole MCB, 6 amps, 1 number. 100 watt, 240 volt lamp, 3 numbers. 200 watt, 250 volt lamps, 3 numbers. Lamp holder, 6 ampere, 250 volt, 6 numbers. Insulated copper wire, 1.5 square millimeter, 5 meters. Make a star connection by connecting a 100 watt, 250 volt lamp to all three phases. Connect an ammeter at line R to measure the line current. Connect a voltmeter between R and Y to measure the line voltage. Connect a single-phase power factor meter between R and neutral. Connect the single-phase wattmeter current terminals at phase R and the voltage terminals between R and neutral as shown in the circuit diagram. Since we are working with a balanced system, only one wattmeter can be used at any phase and the reading is multiplied by 3 to get the three-phase power. Connect the circuit to a 3-phase AC supply through a 4-pole MCB as shown in the circuit diagram. Switch on the MCB and note the ammeter and voltmeter readings and record them in the tabulation. Switch off the circuit. Remove the wattmeter and power factor meter from the circuit and connect them between the Y and neutral. Note the readings in the tabulation. Remove the wattmeter and power factor meter from the Y phase and connect in the B phase and note the readings in the tabulation. Calculate the total power of the circuit by substituting the values of the corresponding meter readings in the formula. Add the 3 wattmeter readings measured from 3 phases and verify the calculated value. Replace the 100-watt lamp with the 200-watt lamp in all 3 phases and measure the 3 power levels. Task 2. Measurement of a 3-phase unbalanced star-connected system. Make an unbalanced star-connected system with different wattages of load at each phase, like a 100-watt lamp at R phase, a 200-watt lamp at Y phase, and 600-watt lamp in at B phase. Connect an ammeter at line R to measure the line current. Connect a voltmeter between the phases R and Y to measure the line voltages. Connect the 2 wattmeter meters, W1 and W2, each ranging from 500 volts to 5 amps. The current coil of wattmeter W1 is at the R phase and the voltage coil is between R and Y. The current coil of wattmeter W2 is at B phase and the voltage coil is between B and Y. You can connect the 2 wattmeter between any 2 phases. To measure the power in an unbalanced load or system, at least 2 wattmeters are required. Connect the unbalanced circuit to the 3-phase AC supply through a 4-pole MCB. Switch on the MCB. Note the wattmeter deflection. If any of the wattmeter deflections are in the reverse direction, interchange the corresponding wattmeter's pressure coil connection alone. Note all the meter readings in the tabulation. Calculate the power factor by using the formula cos pi is equal to cos into tan raised to the power of minus 1 into 1.732 W1 minus W2 by W1 plus W2. Replace the load connected in all 3 phases with a different wattage to create an unbalanced condition and measure the power by following the same procedure. I hope after watching this video, you will be able to measure the power in a 3-phase balanced and unbalanced circuit. Thank you for watching. Have a wonderful day.